Hi, everybody. I'm still Ms. Lee. So we're going to go ahead and go over one more example of simplifying complex fractions. So we are going to simplify x to the negative 2 minus y to the negative 2 all over x to the negative 1 plus y to the negative 1. So at first, you might think to yourself, oh, this is not complex at all. But that's good because it's not difficult at all, but it is still a complex fraction because you have these negative exponents here. So do you remember what negative exponents do? Well, they make it so that you flip it into the denominator. So rewrite negative exponents first. So for example, x to the negative 2 power would become 1 over x squared. And then y to the negative 2 power would become 1 over y squared. And then x to the negative 1 power, that would become 1 over x. And then y to the negative 1 power would become 1 over y. Okay, so now it does look like a complex fraction, and so we can follow the same rules as a regular complex fraction simplification process. So we'll start by condensing the numerator and denominators each into one fraction. Okay, so I'm going to go ahead and find a common denominator in the numerator and then a common denominator in the denominator. So let's start with the numerator. You have 1 over x squared minus 1 over y squared. Since x squared and y squared don't really have anything in common, the common denominator would just be the multiplication of the two denominators. So for the left fraction, I'm going to multiply by y squared over y squared. For the right fraction, I'm going to multiply by x squared over x squared. So what I'm left with then is y squared minus x squared over y squared times x squared. Okay, so this is just the numerator. Let's go ahead and do the denominator as well. So you have 1 over x plus 1 over y. Similar situation. You don't have anything in common between x and y, so you'll just multiply them together. So for 1 over x, we're going to multiply by y over y. For 1 over y, we're going to multiply by x over x. So when you add those together, you have y plus x over y times x. So if you write that as the entire complex fraction, that's going to be y squared minus x squared divided by y squared times x squared, and then divided by y plus x over y times x. Okay, so something we didn't have to do before that we have to do now is that since you multiplied stuff out and you got a quadratic here, you have y squared minus x squared, so you have a quadratic and you have something that can be factored, you should at this point factor everything again. So if there's anything that's not factored at this point in the process, you should be factoring again. So factor everything. So y squared minus x squared, y'all know that's a difference of squares because you have y squared and you have x squared and you're subtracting them. So difference means subtraction. So that is a difference of squares. And so you should be able to rewrite that as y plus x times y minus x divided by y squared times x squared, and then all over y plus x divided by y times x. Okay, so we're going to go ahead and just rewrite this as division. Actually, we're going to skip that step because it's pretty much the same thing as multiplying by the reciprocal. So you know that this is division. So then we're going to multiply by the reciprocal of this. Okay, so multiply by reciprocal of denominator. So basically it'll be the numerator, which is y plus x times y minus x divided by y squared times x squared times, and then the reciprocal of this denominator. So that'll be y times x divided by y plus x. Okay, so you'll see that we have some factors in the numerator that are also in the denominator. You'll see that the y plus x and the y plus x are both there. You should also see that there is a y and an x here, and then there's two y's and two x's here. And so if you think about y squared and x squared, what those are, this is just y times x times x. And so you can go ahead and divide out one of the x's and then one of the y's. So not both, but one of them. Okay, and so for anything that we divide out, as we've said before, anything that you divide out, you need to say in your answer that x does not equal or y does not equal. So for the y plus x, we say y does not equal negative x. You can also say that x and y don't equal 0 because we divided those out. But since we're going to have y and x in our denominator still, you don't have to write those because it's implied. So let's go ahead and write it out. We have y minus x divided by x times y. So like I said, from the denominator being x times y, that implies that x and y cannot equal 0. And so we won't write that as what things cannot be equal to what. Okay. And so there we have it. This is the simplified form of the complex fraction. So let's go ahead and do some practice with multiple variables and negative exponents, and happy day.